In this video, I'd like to show you some selected new features and improvements in our most recent versions of Astrée, release 24.10. I have selected an overview of some improvements and new features. First of all, we have common suggestions, then the improved data flow view, the process graph, a new Taint graph, and some new quality of life graphical user interface features. Let's start with the common suggestions. Astrée now provides the option to collaborate on commenting and classifying findings in Astrée projects. Multiple users can connect to a project at the same time and suggest classification tags as well as comment texts. This works as follows. I have now opened an Astrée client, logged in with username Jason, and with this user I will set up a new project. In this case I will import an AAF. So you can specify a user as an analysis owner, which will be the user Jason in this example. This user initially creates and sets up the analysis, and this user alone can modify analysis settings, pre-process and run the analysis, and create alarm classifications as well as alarm comments. So once this user has successfully pre-processed and run the analysis and produced findings as alarms, he can add both classifications and free text comments to those findings as usual. Let us pick an example. Let us classify this finding as true with a free text comment. The new collaborative comments feature now enables other users, for example Jill and Sean, to connect to the same analysis project that Jason set up. I will now change the user and connect to the same project with a different user, username Jill, and open the very same project that we just set up. Here you see the indication that user Jill is not the owner of the analysis. Still, I can open the findings view. I will see the other comments, in this case Jason's comment. And I can proceed as follows. Choose a finding of your choice and a classification of your choice. Add a free text comment. Then another user, let's say a third user called Sean, will connect to the same project. And again, open the same project. Now let's open the findings view. And I can now see that there is a pending comment suggestion for this alarm number 7 from user Jill with classification true low and the comment text Jill's comment. Now I, as user Sean, can choose the same or a different finding and classify it with another note here. Let's call it Sean's first comment. I can also do this with a different finding. Now I am the first one to propose a comment suggestion. Let's call it Sean's second comment here. And now let's see what user Jason, who is the owner of the analysis, sees as pending comment suggestions. So let us switch user again to user Jason. Again, he is the owner of the analysis. The analysis owner is then greeted by this info message, which indicates that there are unreviewed common suggestions for this project. You can then open the new contributors view by either clicking on this button here or by navigating to Settings and then clicking Contributors. This will open a list of users who contributed with their common suggestions, and by default all of those contributors are pre-selected, so that we can simply click on this Display Findings button up here to open the findings view and filter for exactly those findings where those users contributed to. Those findings with common suggestions are shown by a small light bulb symbol here. I can now select a finding to open a common suggestions subview, where I can review all common suggestions and accept or reject individual or multiple suggestions. If I accept a common suggestion, it becomes a regular comment in the project. Let us, for example, reject Sean's first comment and accept all remaining common suggestions. They now have become true comments. We have added a new quality of life feature for our data flow view. Additionally to the range of byte offsets, the data flow view now also shows the access paths where applicable. I have now opened the global data view on this project, and now I choose some variable, in this case the first variable array1 glob, which is an array. Now this will open the locations view, and we now can see the byte offsets in this array1 glob variable of 38 in this case and 9 in this case, etc. In the case where these paths may not be precise enough, a tooltip is associated with each byte offset range to display exactly what the analyzer knows about these offsets. Astrée now provides a process graph. This will help to keep track of your project's process structure. To view the graph, just open an asynchronous project. I will open the OSEC AutoSci example, which ships with Astrée. Then run the analysis and navigate to Results, Process Graph. Here, each vertex represents a process, while each directed edge from node A to node B represents that process A starts process B. If I increase the drawn graph depth, like you probably already know from the control flow graph, we can see that process 13, which runs function alarm 2, starts process 4, T2. Process 4 is also started by process 0, core init, as well as by itself. With a right click on a node, you can open the context menu, which provides you with options to show the core graph for this process, jump to the source code of the entry point of the selected process, and show the process graph for the selected node. Starting with version 24.10, Astrée now offers a new method to visualize taints and their propagation, the taint graph. To use the taint graph, configure your project with the desired taint behavior. I will open the example non-interference analysis, which is shipped with Astrée. Ensure that the new option Build Taint Graph here is set to yes, and run the analysis. Let us take a look at the findings. We have a few taint sync alarms, so let's filter for them. Now this first finding here tells us that a taint called wheeled position has propagated into a sensitive area or taint sync. Concretely, in this example, the movement or position of the vehicle's steering wheel must not interfere with the mechanism to add AdBlue to the combustion process. We can now take a detailed look at the situation. I will now open the taint graph via results taint graph. And on the left side, we see a list of project components marked by a small C letter, as well as taints marked by a small and lowercase t letter. I am interested in the wheel position taint, so I will expand that entry. And we can see that there are multiple affected variables. I will choose this control at trusted AdBlue variable at offset 0. And on the right side, the relevant graph for our selection is now drawn. This directed graph tells us exactly where and how the taint is propagated. The top node represents the taint wheel position, and the edges represent its propagation. Our taint then affects at least one byte within the variable SW_pos, which is indicated by the corresponding node as well as the X in brackets. Following the edges further, we then reach a code location where a control flow decision is affected by the taint, which is indicated by the decision tree symbol. You can easily jump to those locations if you right-click on the edge label and then choose View Source or press the hotkey G. CTRL is a parameter of this function, which is part of the assignment to AGR. Let us go back to the taint graph and investigate one more step. That is the propagation of signals.c in line 137. This is the function call to this trusted AdBlue function, where the argument again depends on the evaluation, in which a tainted variable SW_pos is involved. I can also double-click on a node to unfold it and display additional information like the call context in which the variable has been affected with a taint, or the control flow decision has been taken. With this graph, Astrée provides a great tool to keep track of taints and its propagation. We have also added many further quality of life features to our graphical user interface. To mention some examples, we have improved the Find in Project functionality. You can now simply position the text cursor inside of an identifier and then press the keyboard shortcut Ctrl, Shift and F. This will open the search view and automatically start a search for the selected identifier. If you press the Control key and click on a function call, the editor now automatically jumps to the function definition. You can also use the control click to automatically open the locations view, which will then show the caller-callee relationships. Note that the editor now shows information at the beginning of a function. This information includes callers and callees, as well as findings regarding the corresponding function and a direct link to this function's call graph. Those items are clickable. If I click on 10 findings, for example, the findings view will open, which will only show those findings relevant for the selected function. While I click on call graph, will display the call graph from the perspective of the corresponding function. As always, we have implemented more improvements. For example, the C++ front end now also supports incremental preprocessing, parsing, and rule checking. Then on multi-core systems, we have produced a significant speed up in terms of preprocessing and also parts of the rule checking due to multiple Clang front-end tasks, as well as many more improvements. Let us know anytime you have any question or feedback at info@absint.com. Also check out our website for a complete list of release notes, absint.com. Thank you for watching.